Bienvenue à Nick Does Maths. Welcome, welcome everyone. Tis me, tis Nick. We're going to do some probability today. Now, before we start, we're going to use a result which I have recapped up here for this infinite series that I showed this result on one of my TikTok videos. The link will be in the description. So please do go check that out. But we are going to use this later in this question. Now, here's the situation. Arthur and Boadicea, hereforth referred to as A and B affectionately, as their parents always referred to them, are shooting arrows at a target. The probability that A hits is A, funnily enough. The probability that B hits is B. Okay? Woo! Whoever hits first wins, and Arthur or A gets to go first. Lucky, lucky Arthur. The probability that A wins is alpha, and probability that B wins is beta, because we are full of imagination like that. We need to show that the alpha, i.e. the probability that Arthur wins, is A over 1 minus A dash B dashed. Standard notation is that A dashed is 1 minus A, and B dashed is 1 minus B. We'll do the same thing. We'll then find an equivalent result for B dashed, and we're going to show that the expected number of shots required over the course of this contest is this. All set? Good. Right. Let's go. So, where do we start? Show that the probability of A winning. Now, there's a number of ways we can do this. One of them, which is really cool, is partitioning on the first shot. But really, let's just do it in a fairly nice and straightforward infinite series way. For A to win, for Arthur to win, he could hit the target first. Or he could miss, then B needs to miss, then he needs to hit. Or him and B could both miss their first shot, their two first shots, and then he hits. Or A and B both miss their first 3 shots, then Arthur hits. So really, this is an infinite geometric. First term A, common difference A dashed B dashed. Nice and simple. Now for B to win, beta. Well, what needs to happen? Well, A needs to miss, then B hits. Then A needs to miss the next one as well, needs to miss 2. B needs to miss 1, and then B hits. Now, if we have a look at this, what this will be is, so then A dash misses 3 times, B misses twice, then B hits, so on and so forth. It can easily be shown that this is just, again, it's a little bit harder to see, but this is an infinite geometric with first term A dash B, and then the common ratio is a miss and a miss, so A dash B dashed. Have a look, right? First term, if I could even spell first term, all right, just to be absolutely crystal clear here, this is an infinite geometric. First term A, common ratio is A dash B dash, and this one here, first term A dash B. Check that you are happy with that. Okay. All the way down. Now we need to find the expected number of shots. Right. So, expected number of shots. What could happen? Well, how does the game end in 1 shot? If A hits the first shot. How does it end in 2 shots? Well, 2, A misses, B hits. 3 would be they both miss, and then A hits. 4 would be A misses twice, B misses once, then B hits. I'll do a couple more. 5 would be 2 misses from A, 2 misses from B, then A hits again. 6 shots would be 3 misses from A, 2 misses from B, and then B hits. Now, this was a hint we were given at the start of the question, so we're going to try and make that appear. And to do that, what we're going to do is we are going to pick out certain terms. So in blue, and what I'm going to do is, with these terms here, I can take out an a, and I'm left with a times 1 plus 3a dash b dashed plus 5a dashed b dashed squared. There'll be a 7a dash b dashed cubed dot 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 dot. And if I take the even terms, and I'm going to take out a 2a dashed b, and I'll be left with 1 plus 2a dash b dashed and if we keep going, right. Now, if we compare that to what we've got over here, this is just this thing up here, right, in blue. That is just this result here with R is A dash B dash, that's obvious, and D is equal to 2. Right, if we make this D is equal to 2, we're going up in 2's, so this is D is equal to 2. Whereas the red one is going to be D is equal to 1. All right. So, a couple of things I'm going to do, because I'm going to need the upper part of the board for the rest of this. I am just going to write down that B dash, we did that, get that, that's A dash B over 1 minus A dash B dash. All right. Trying to get a little bit of space up here. So what are we left with? So this is A times, I'll do it in blue again. A times 1 over 1 minus A dash B dashed plus, we said D was 2 A dash B dashed over 1 minus A dash B dash squared. That is the R, that is the blue gubbins. And I just get D is 1. All right. Now it's time to do some algebra. Now it's time to do some algebra. Let's do some algebra. So that is A times, let's just make one big 1 minus A dash B dashed all squared. So that becomes all of that. Right, so what do we end up with? We end up with A times 1 minus A dash B dashed plus 2A dash B, and that's just 1, all over 1 minus A dash B dash squared. Right, so this is where we're at so far. Now, we want to get to alpha over A, beta over B. Now, one thing to notice is maybe have a little look-see at what it is that we want to get. So if we do alpha over A, I'm left with 1 over 1 minus A dash B dashed. And if I do beta over B, I'm left with A dashed 1 minus A dash B dash. So importantly there are only dashes. So let's try and get rid of all the non-dashes. So this is going to be equal to A is 1 minus A dashed, and B is 1 minus B dashed. Come on, we can do this. So what am I left with? I'm left with 1 minus a dashed minus a dash squared b dashed. No, plus a dash squared b dashed minus a dash b dash. Here, plus 2a dashed so that is 1 plus a dashed plus a dash squared b dash Is that what I want? That's a plus. Who's been shouting at their screen? So those are the other way around. There we go. That looks better. Now, the reason that is important to me is because that is 1 plus a dashed times 1a minus a dash b dashed. And what you'll see is those two cancel out. And we are left with 1 plus a dashed over 1 minus a dash b dashed, which, as mentioned before, is exactly what alpha over a plus beta over b is. We got there. We just about made it in the end, with a little bit of double checking of work. Right, as always, please drop us a like, leave a comment, follow the channel, hit the bell for notifications, and we will keep making this content, going through all these styles of, I think this one was a uni admissions, a step question right there, just to help you on your further maths journey. From me, Nick here at Nick Does Maths, I will see you next time. So, bye-bye.